or you add the two events and then you subtract anything that occurs at the same time. If it's mutually exclusive, then that means they, what's that? Oh, you were going to take it now. Okay. Huh? Okay. Sorry. Brain. Figure out what it is. That's right, we did talk about that. I don't think that's what I was going to tell you, though. Okay, grab you a calculator. Have I assigned you one, or you have one? Have I assigned you one? Oh. Just take the top one. We'll work now. You don't have your phone, do you? There it is.
There's nothing wrong with big glasses. You just gotta get used to them. I kind of wear them my whole life.
They're bigger than I thought they were, so I kind of look like that picture of a bookworm, you know?
I don't think so at all, but
I think your hair's too curly for that, to be honest.
What?
I don't know why, but in my mind, that's why.
That's great.
I reckon.
Okay. I'm just going to move on. Here we go. So, sometimes you're given a picture of something. These are cards, but these are different cards. They have numbers 1 through 5 on them. And they have birds, lions, frogs, and monkeys. And we want the probability that it's a monkey or an even number. So that's why I have monkey or even, M or E. So of course you're going to do probability of a monkey plus probability of an even number minus the probability that it's a monkey and an even number at the same time. Can you have a monkey and an even number at the same time?
Yes.
Yes, you certainly can. I've actually drawn arrows to them. Forgot to erase those, but that's okay. So let's talk about the monkeys first. How many monkeys are there? 5. These are the monkeys down at the bottom. And out of these cards, how many cards are there? How many? 20, yeah. Now remember, I don't reduce these until the very end. Now even, look at all the cards. How many even cards are there? 8. I'm sorry. You may have said that. I just didn't hear. Yeah, the 2s and the 4s. So it's a total of 8. And then we've already talked about this, but yes, you can have a monkey that is also even. There's 2 of them. So I have to subtract off 2 out of 20. Have I lost any of you yet? Okay, cool. So, adding 5 plus 8 is 13, minus 2 is 11. That will not reduce, so your answer is 11/20. That's probability that you just randomly pick a card and you get a monkey or an even number. and probability. So we're going to start the and probability stuff today. Just couldn't quite get through that last problem yesterday. But that's okay. We need a good little review. And problems are, you multiply the two probabilities. So you take each probability, each event, and you multiply. Notice I don't have to worry about subtracting anything off. I don't have to worry about that because notice there's no subtraction up here. I just take the probability of each one and just multiply them together. Okay, here's something important. Always assume that event A has occurred when calculating probability of B. So whichever probability you're looking for first, that one's already happened before you find the second one. It's very important. Now, and's going to involve more than one thing. Thus, and. So it'll include with replacement and without replacement, like we talked about on 6.5 on the tree diagram stuff. So again, if you haven't done that assignment yet, please go do that so that you can make sure you understand that stuff. It's definitely going to play a role in this. Okay, so here's our problem. We're going to select two cards. Notice it's two. And it says with replacement. That's important to know. From a deck of cards, so regular deck of cards, we're going to find the probability that two aces will be selected. Anybody need the picture of cards? There's no shame at all, I promise. Some people grew up with cards, some people did not. It is okay if you did not. Okay, because I'm not going to flip back and forth. If you need a picture of cards, I'm just going to bring you the book and show you where it's at. I will put it on Google Classroom. It just wouldn't help you right now. Okay, so we're finding the probability that two aces will be selected. So that's probability of ace and ace. So that means we're going to take the probability of an ace times probability of an ace. And this is super important with replacement. Means you reach in the deck of cards, pull out an ace. Then you put it back in, and you reach in and pull out another ace. Okay, so let's talk about probability of aces. How many aces are in a deck of cards?
4.
4. How many cards are in a deck of cards? Yeah, remember 52 card pickup? Anybody play that with you when you were young?
Mm-hmm.
Yeah. Especially if you have an older sibling. Still remember my brother doing that to me. Because I was so excited because he was going to play cards with me. He was like, yeah, I'll play. Let's play 52 card pickup. I was like, yeah.
There wasn't even any siblings or anything did to me. It was in band, Mr. Brinkle used to do it to us all the time.
I have the utmost respect for Mr. Bird. I think he is awesome. My kid
I do too, but he
loves
was just
him.
like, come on guys, we won't practice today, but if y'all want to play games, we'll play 52 card pickup. And he got like 2 decks and spread them all over the place.
Oh, no.
Okay.
That would be 104 card pickup. I'd be like that.
It was crazy.
Okay, so we picked the ace. We put it back in. So remember, you have to assume that you've done one before you do the other. But since we put it back in, the second probability is exactly the same. So now when you're multiplying, it's best to reduce first. So it's not like the addition and subtraction problem. So if you didn't get your grab me try that again. Grab your calculator. You're going to need it for sure for this. Because we're going to be multiplying pretty big numbers.